So, hello everyone. This is Hiren. So, welcome to the YouTube channel. As you all of you know, we already started the subject that is software engineering. We have seen up till the two chapters. The chapter number one is all about the software engineering introduction. The chapter number two we have seen about the software processes. And the chapter number one we have seen exactly what exactly the subject is all about, or what it will be there in the subject, what exactly the software engineering process is all about. In the chapter number two we had more focused on the software process. Yes, we have seen the generic process framework. We have seen the layered technology or in the chapter number two software processes. Okay, then we have seen the immature software processes. We have seen the immature software organization in the chapter number two. We have also seen the capability maturity model, the CMM level 5, total 5 levels, CMM level 1, 2, 3, 4 and 5, what exactly they are and how they are helpful to improve the quality of the process, and ultimately at the end result would be the quality software. Okay, so there were the five categories according to the five category companies: CMM level 1, CMM level 2, 3, 4 and 5. Okay, so this was all about the chapter number 1 and chapter number 2. Today we will be starting the chapter number 3, that is the perspective process models. So in this chapter we will get into detail about the more about the software models. So in the chapter number 2 we have seen the process, what exactly the software process is. We have seen the quality process, how you can make the quality process. If you remember that, we have seen the generic software process framework, like how that particular process framework applies into the software engineering. So in the software engineering there are the different types of process. Yes, process uh, can be in the different type. Let's say if you want to achieve a goal, you might have the different plans to achieve your goal. Let's say if you are working on any project or if you are doing anything, so to achieve that plan or to achieve the target, you will have the one plan. One of your friend will have one of your friend will be having the another plan, so the plans can be different. Similarly, in the software also, in the software engineering process also, there to make a software there are the different plans available, there are the different types of software processes available, that are called the different software processing models. So in this chapter we will study about the different types of software processing models. Okay, so again and again we will be coming. So this is the overview of the chapter that will cover the generic process framework that we have already visited. Okay, but still we have to cover it, because this is the framework which will apply to the all the models. So this is a one type of model also, that is the generic process framework. Then we'll have the traditional process models, specialized process models and the unified processes. So we will see this in a one by one into the next videos. Okay, so the next slide. Yes, the generic process framework, we have already seen that communication involves the communication among the customers. Between the customers means your clients and the other stakeholders like the project manager, encompasses a requirement gathering. Yes, yeah, we have taken the example of the grocery delivery app, making a grocery delivery app in this pandemic situation. We have taken the real-time example of the communication between the grocery vendor and the project manager. Okay, then the planning. Once you capture the requirement, you will store that requirement into the SRS document, that is a software requirement specification. Once you do the planning, then you will store sorry once you do sorry you will develop a plan sorry you will develop a SRS document. Once you define a SRS document, what one have to do, one have to prepare a plan. So what exactly the plan is all about? Plan is all about the scheduling your task. As we have taken the example, if your project takes a 3 months of length, then you have to decide what you will be doing into the first month, what you will be doing into the first week, first day, how many resources you will be there. Let's say to complete a project you will require 4 person. So on the first week what the first person will do, on the week what the second person will do, on the third week what the third person will do. So you have to prepare your plan accordingly so that you can meet your end deadlines ultimately with the quality software. Okay, so once the plan has been done, you have to apply the proper modeling. So in the modeling we are considering as analysis as well as design. So as I told you, here we are talking about the designing, not in the terms of HTML CSS. We are talking about the designing in the terms of paperwork, in the terms of diagrams, in the terms of it's a whole architecture you will be defining into the modeling. And there are the different diagrams, UML diagrams, unified modeling language diagrams will be used, class diagram, object diagram, data flow diagram, data dictionary, to visualize whole your requirement into all the diagrams. Once your modeling is done, most probably 40 to 50% of your project will be completed. Then this modeling will be handed over to your implementation team. Let's say if you want to develop your software into the Java, so the development team of Java will analyze this modeling part and convert that modeling into the real-time software with the Java technology, or any other technology. We are just taking the example of Java, right? So in the meanwhile, we have taken the example of the testing is so much important on the side by side. When you are developing, let's say if you are developing a e-commerce site like a Flipkart, let's say once the login module is done, there should be the proper testing. So you'll have the testers team of the testing which will there to find the bugs into the system. So we have seen the all the processes between the finding the bug and resolving the bug between testing team and the coding team. Once all the bugs have been resolved, then the product will be like ready to go into the market. Okay, so and then comes into the deployment. Once a deploy, the customers can access the product. So this was the generic process framework. We have already seen that. uh, Yes, modeling, it shows the helps software engineers to better understand the problem they will work to solve, encompasses the set of tasks that lead to understanding of what the business impact of the software will be, what the customer wants, and how the end user will interact with the software. Okay, so ultimately what we are trying to say with the modeling is that it is like you are mapping your requirement into your visualization. And for that visualization, we have the different kind of diagrams, into, right? So uses the combination of text and, see written here, uses a combination of text and diagrams to depict the requirements for the data function and the behavior. So ultimately the modeling is nothing but is your conversion from your requirements into your visualization, we can say that, right? Then software modeling is software design. Ultimately I'm again saying design, not the HTML design. It's your the paperwork, like brings together the customer requirements, business needs, and technical consideration to form a blueprint for a product. So ultimately a blueprint nothing but a whole bigger paperwork, which you will create a software. See what exactly the blueprint. Before, let's say if you want to construct a home, you are not directly going to like get all the material and start to work on that. You will have one architecture who will design the layout of your, or the architecture of your home, and like a civil engineer will do all this stuff, and once it is ready, that will called as a blueprint, and basis of that blueprint that all of your construction will be built upon. So similarly in the case of software also, before starting the software we have to prepare the blueprint. So blueprint is nothing but we have seen that the modeling, that is a software modeling using the different types of diagrams available. Okay, so what we are saying further, that is a creates a model that provides detail about the software data structures, software architecture, interfaces, components that are necessary to implement the system. Okay, so what exactly the model is? Model depicts the software architecture, which type of the software architecture will use, which type of interface will be there, and which type of the components will be used. So there are the different types of modeling available. The first one is the architecture design, the second one is the user design, and the third one is the component level design. So let us go into the detail by one, like what is architecture design. So architecture design represent the structure of a data and program components that are required to build the software. Considers the architectural style, the structure, and the properties of the component that constitute the system and interrelationships that occur among all the architectural components. So what exactly the architecture design is? Let me give you the example. Let's say you are developing a library management system, right? You are developing a library management system. So when we if you are any if you know any object oriented programming languages like a C++ or Java, so we have to define the several number of classes. Let's say a library class, a book class, a employee class, and the student class. So we will define a class, n- but in some graphical manner in the architecture design. We will define let's say a library class. We will define let's say the book class. We will define let's say employee class, but in the graphical format. We will define the relationship between the library and the employee. We will define the relationship between library class as well as the student class, book class, and the student class. So all this happen in this architecture design, which shows the interrelationship between all this in all the components, data flow between the all the components. Also we will define some data flow, like where the data is going from, like from student to book to library to admin and all that. So the whole this design comes into this architecture design part. Then you will have the user interface design. So ultimately this is shortly called as a UI design. So generally when you access any website, let's say a facebook.com or Instagram or a Facebook, when you search into the Google, like let's say google.com, the what you see ultimately nothing but the user experience. It is nothing but the user interface design where the user will interact. So what we have done into the architectural design, what we have done into the architecture design, that is a backend work that will happen into your coding. This work, this will not be able to send to the user, like and let's say if you are defining a library management system, so whatsoever you will define into this architecture design, your students or your end customer will not able to see this. While in the case of user interface design, yes, your stakeholder in the library management system, your student will access this portal with the user interface design. So are you getting my point? When you access a facebook.com, that login page of the Facebook page is the user interface design of the Facebook. So this is the first type of design, that is architecture design. The second type of design is a user interface design. Third type of design is a component level design that defines the data structures, algorithm, interface characteristics, communication mechanism allocated to each software component. So this is we can say the more detailed level, like let's say if we are defining any class, so which data structure we will use, which type of algorithm we will use, how the data will be communicated between the two components, like let's say the two classes, we can say student and the book, admin and the library. So in the detailed designing will be covering into the component level designing. So yes, so this slide includes the more detail about the modeling. So up till now what we have seen, that is a basic generic process framework. We have seen the overview, like what it is happening into this. Now we are starting to digging more into the detail. Like we have seen the modeling. Yes, modeling is about your model your requirements. It's ultimately modeling is nothing but giving a visualization to your requirements. It's nothing but the modeling, or we can say that the software design. Okay, I hope you are much more clear now. Okay, so this was about the generic process framework we have seen, which will include the communication, you can say the planning, you can say the modeling, code and test and deployment. Okay, so this was generic process framework. Now we are looking for the traditional for process framework that was followed previously. Now we have the different type of, yes, I told you, as of previously we were talking as a framework, now we'll be considering as a models, different types of models. So we are seeing the first model, that is a traditional process model. So in this model, or we can say the prescriptive word process model, defines the distinct set of activities, actions, tasks, milestones, and work products that are required to engineer a high quality software. The activity may be linear, incremental, or the evolutionary. Okay, so this terms will be explained into the detail once we cover all the modules, all the modules. But for that we have to understand the one of the model to understand this line, okay. So we are starting about the generic process model. So this is a very traditional, very well known, previously followed model, that is a waterfall model. So this is nothing but the one of the software process model which will include the different phases like communication, planning, modeling, construction, and deployment. Yes, you can say that your generic process framework is ultimately a waterfall model because it will follow the steps one by one after one. The step number one will have the communication, which will have the project initiation, requirements gathering, like a communication with the client. Any projects come to you, you have to communicate your requirement properly with the client. You have to capture the requirement properly, like like because you have to capture a requirement properly, because let's say before signing a project, if you are not understanding a requirement properly, so what you will develop ultimately which will not be acceptable after the end of your software process. So it is a very much crucial task, to understand the requirement of a client, to understand the requirement of a client to understand the requirement of the project, understand because based on the requirement you have to decide the timeline, like how much time the particular software will take. You have to define the budget, how much budget your software will take, how many persons will work on the project, which technology will be more feasible, more use more feasible for this particular technology or the particular requirement. So it is a very much crucial stage. So I must say that this phase, this this thing will be handled by the very much senior level person into the company. Like juniors are not given to this authority, like they don't have that amount of experience to properly capture the requirement and properly understand the requirement. Okay, so this is a very much crucial steps for any software process models. So in the waterfall model, the first phase number one, that is a communication with the client, which will include the project initiations and requirement gathering. Okay, once the requirements is gathered, then there will be the feasibility study, how this project will be achievable, how this project feasible or not. Once all this done, all this requirement will be stored into the one documents. That documents will be called as the deliverables. Now you will be asking what will be the deliverable. Like let's say if you are doing any work into the one phase, this is your phase number one, that is your communication phase. What will be the output of the communication phase? That is your software requirements in the form of document. That document called as a SRS, that is a software requirement specification. So it is nothing but the deliverable of the phase number one. Okay, so it is nothing but the deliverable of the phase number one, that is your SRS. Okay, so as again I'm saying, that is once the stage number one is completed, then the next phase would be the planning, like estimating your project, like according to the requirement, how much it will take. Let's say it will take the 4 months of time, how many persons will be there to complete the project. If you want to complete a project into the 3 months, you have to use the 4 people. How you have to divide the task, what a particular person will do into the first week, second week, third week, and fourth week. Not only the planning, you also have to provide the tracking. You have to use the different project planning tools and tracking tools. Like let's say the Hiran is doing what Hiran is doing today currently. Is he completing the task today or not? What he will be doing tomorrow, and also. So this all things are very much important, that is into comes into the planning. Once all the plan is ready, then actual a project work will be started in the terms of the modeling, we can say the analysis, or we can say the design. Okay, so ultimately I am saying again and again, we are talking about the architecture, we are talking about the paperwork, we are talking about the blueprint in the terms of modeling. Your whole software requirements converted into the diagrams, use case diagram, class diagram. So what are this diagram? These diagrams are nothing but your uh, grammatic. Sorry, it's a diagrammatic representation of your text of your requirement. So it will be more easily understandable. It's a technical representation. Let's say if I give you the example, let's say if you, again I'm giving, take the example of the library management system. Again, let's say we are going to develop a library management system, then yes, we always need a library class. So to define a library class, we have some notation like a rectangle box. So in the rectangle box we will define a library class, we will define another student class in the another rectangle, we will define another class into the another thing. Okay, so these are the things. So let me give you the example. Let's say if you can, let's say UML diagrams. Okay, so just you can see the images over here. So this is the example of the class diagram. If you can see that, yes, this is an example of the class diagram. So this is nothing but your customer. This is one rectangle is your one class. The name of the class will be the customer, you can see that. And this, in you will have the two parts. On the upper part is a variable of the class, and the lower parts will be the method of the class. So this is nothing but a simple order management system which will have the customer class, order class, stock class, and the product class. Okay, so ultimately what they have defined, they have converted stock management requirement into the class diagram. So now the task of the developer will be much more easier. He just have to create a class customer, he has to define the variable defined over here, he has to define the method defined over here. Okay, so this is the reason why I told you, once you have done the modeling properly. So see, first of all, once you have gathered the requirement properly, you and your next task will be a much more efficient and much more easy. Once you have captured, once you have done the modeling properly, once you have defined the proper classes, once you have defined the proper variables, proper methods, then your implementation would be more easy. Once you have implemented your code properly, your testing would be more easy. If you had done your testing properly, ultimately your end product will be the quality thing. So each phase are dependent on the another phase. If you are doing a quality thing in one phase, your next phase will always get the quality work. If you are doing the quality work in the next phase, your third phase will get the quality work. So this cycle moves on. So are you getting? So this is a class diagram. Let me see you the another diagram. Let's say use case diagram for let's say a library management system we are talking about, right? So let me give you the example. So can you see that? So this is a use case diagram. So this will show you the overview of the system, like which are the main features a particular system will have, like a register a number, issue the book, check the availability of the book, return the book, calculate the fine, and all these things. So these are the main features like the end customers will be having into the system, which will be shown with the use case diagram, right? So I hope you are getting my thing. So this diagrams called as the UML diagram. So these are the one of the examples. There are so many diagrams. Let's say one of the diagram is the activity diagram. One of the diagram is activity diagram. In the activity diagram we will show the exactly the activities. Like let's say in the library diagram, the user enters into the browser, search a system, login into the system, search the book, issue the book, and after 10-15 days will return the book. So this is the activity. We will show exactly the activity with also the activity diagram. Yes, so ultimately there are so many different types of diagram which will covered into this modeling part, right? So in the modeling part, what you are doing ultimately using all this UML diagram, class diagram, object diagram, activity diagram, use case diagram, sequence diagram, which will show the sequence of the processes. Okay, so you will be converting your requirements into the uh, visualization. On the paper you are converting your requirements into the visualization. Okay, so let's say if you are doing your phase number 1, 2 and 3 properly, almost your 40 to 50% of your software development work is completed. And now the next term comes into the coding, or we can say the testing with the coding. So what will be now the task of the coders, or the now task of the developers will be much more easier, because what they will do, they will use this designing. Let's say if you we have taken the example of the order management system. They will they have already defined the customer class. They will just do it on a coding Java, Python or .NET. The variables are already defined, methods are already defined into the modeling. They just have to convert that modeling into the actual implementation. That modeling into the actual implementation. Okay, so so this is the very basic and important thing that we have to actually understand, right? So uh, so not only the coding, let's say any code or any developer are developing this anything. Apart from this, he will do the initial testing, not the final testing. Once let's say he will developing any module, then that module will be given to the testers to test a particular code. Let's say, so what will be the task of the testers? To find the bugs. Like whatsoever the developer, his the task of the testing team to find the bugs, to find the problems into the system. Any bug they will post to the developers, hey, you have developed this system has so many bugs, this much of bugs, you have to resolve this as much as possible, because this product cannot be going to the market with this bug. So now again, your developer what will do, get the bugs from the testers, resolve the bugs into the particular time, again give system to the testers. Now testers will do the whole testing again, because it might be possible that resolving a one bug can affect another issue on the another module. Okay, so they have to do the proper testing again and again. So if they found again a bug, they again will transmit the code to the developer, say, hey developer, still you have the bug, please resolve it as soon as possible. Okay, again the developer will resolve the bug and give code to the test. So this cycle, this process will in the loop will go on until and unless your product is bug free. Until and unless your product is bug free. At the end, once both are like mutually agree, yes it's fine, now that product will be given to the production, like the to ready going to the market. It will be like a deployment means into like giving to final delivery to the client, to be like a hosting onto the any server, like finally delivery. So this is not a overthink, like this is not overthink, like once you are giving a product to the client, your task is not over. Yes, you will get the money, you have completed the project, but you also have to do provide the service, you also have to provide the support. It might be possible that like your website is running good onto the 10 users, but when client is using with the 50 users, your website like a chalk up. So you have to provide the support for that also, right? So it support will be like decided into the initially like 4 month support, 6 month support, or a 1 year free support. After the 1 year they will take some amount of charge and all that, and some amount of maintenance charge and all that. So these are the supports this are provided. So this is nothing but a waterfall model. Why? Because its shape is like a waterfall, step by step. Phase number 1, this is a communication. Once it completed, then the phase number 2, that is a planning. It's completed. Phase number 3, modeling. Phase number 4, construction, which is the code and test. And the phase number 5, that is a deployment, delivery, support and feedback. Okay, so this was the one of the software process model that we have will be seeing most into. There are the different types of models. So this is a previous, this is a very much old one, this is we can say the very much traditional thing, which does not include the risk management, which uh, which is feasible for specific software requirements. It is not like that it is applicable to all softwares. Yes, we will see the different types of software model into the further chapter. So up till now, we'll be putting like up to this. So thank you very much for watching a video. We'll see meet in the next video. Thank you very much.